right. In Adab Boost, if you remember, towards the end, when we combine the results, okay, we have taken some 0.42 because that was, I think, the alpha value. Plus, again, we got 0.52 into the next classifier value plus 0.62 into the next classifier value. We have given some weights to each and every iteration. And in each iteration, there was one decision tree built. Decision tree with depth equal to 1. Here also decision tree with depth equal to 1. Here also decision tree with depth equal to 1. But in gradient boosting, you'll have decision trees with varying depths, point number 1. And here, however, in gradient boosting, when we assign the weights to each tree, the weights that we are going to assign will be constant. In Adab Boost, the weights were changing. But in gradient boosting, the weights will be constant, and that constant is called as a learning rate. Now, let's get into the explanation. Everything that I'm going to talk about would be here. Everything would be here, but I would resort to my way of explaining. So the first step within gradient boosting is as follows. First of all, you need to define something called as a learning rate. And this learning rate value ranges from 0 to 1. In neural networks, you'll understand more about the learning rate. Point number 2. You calculate the output variable mean within the data set. I'm giving an example where output variable is continuous or numeric. Okay, I'm talking about a regression problem here. So you just take your output variable and calculate mean of that. And this would be your baseline model. This would become your baseline model. And this average value would be used as the initial prediction value. Initial predicted value is going to be this. So you take your average. You put this average throughout. So you have 100 observations. If you subtract this, which is being now treated as the initial predicted value, with the actual value, when I delete these two, when I subtract these two, what do you get? When you subtract predicted value from actual value, what do you get? Error, absolutely. Those errors are also called as residuals. Subtract these two, which is nothing but predicted value minus actual value. When you subtract these two, you get residual. Or error. Are these errors that we are calculating based on a predicted value or based on the average? It's based on average. Now you're taking this average and you're considering this as a pseudo predicted value. It's not the actual predicted value. You're just taking average of your actual value output variable, and you're starting to treat this as a some pseudo number, right? It's not actual predicted value, it's a substitute. And when you subtract these two, you're getting residual or error. This is actually not predicted minus actual. You're treating this as pseudo. So these are called as pseudo residuals. Pseudo means some kind of a dummy. Okay. Now what you do is, you take your inputs, x1, x2, x3, say you have those. Take your inputs. However, you start putting your pseudo residuals as your output. Pseudo residuals as your output. And now build a decision tree on that. Build decision tree on this dataset. Okay. So when you build your model, what do? Once again, you split the data into training and test. Okay. Or if you want, you can start treating this entire thing as your training data set. That's it. If you start treating this entire thing, so in the initial data, if you have 100 observations, here also you'll have 100 observations. When you build a decision tree on the data set, you use that model to predict on the same data set. When you build a model and then predict, what do? You take all these inputs, and when you predict, when you supply these inputs to your model, you get a predicted value. And then you anyways have the actual value, which is nothing but pseudo residuals. Again, supply the next set of inputs to your model. Then you get the predicted value, compare it or subtract it with the pseudo residual value. Again, what do you get? Residuals, errors. Okay. Now, okay, what I'll do is this particular thing, I'll just explain at this point of time. So here, the final prediction is equal to average, because we are calculating the average as part of the initial step, plus we define some learning rate, and learning rate should be smaller than 1. Say you choose a value 0.1 as a learning rate. So plus 0.1 into, multiply that with all of your predicted values. Okay. From where are you getting those predicted values? Here. When I build my model and predict, I get all the predicted values, right? Take all the predicted values and multiply it with. So final prediction is equal to, in the first step, you are anyways calculating the average as predicted value. From the second step onwards, what do? Learning rate into the predicted values of this first iteration. Plus, what should we do next? Okay. So once you get all the predicted values and subtract it from the actual values, what do you get again? Residuals. Use those residuals and take the inputs from the original data set. Okay. And take these pseudo residuals, take the inputs, again build a model. And once you build the model, what do? You use that to predict on the data set. Once you predict, you get predicted values. Okay. You get the predicted values for all these 100 observations. Take each of these predicted value and multiply it with the learning rate. So P2 means all the predicted values of iteration 2. Then subtract these from the actual values. When you do that, what do you get? Again, residuals, pseudo residuals or errors. Take these pseudo residuals and make these pseudo residuals once again output variable, and take your input variables from the original data set. Again, build your decision tree. And once you build your decision tree, predict on the data set, and then you get the predicted values for all these 100 observations. Okay. Once you get the predicted values, you multiply those predicted values with the learning rate. And then when you subtract it from these actual values, what do you get? Again, you get pseudo residuals. Again, for the next iteration, take these pseudo residuals as output, take these inputs, again build the model, predict. Keep continuing to do that for as many iterations as possible. Number of estimators. How many ever estimators you want? Run it 100 times, 200 times, 300 times, 400, what your wish. Okay. So this is a rational, and this is how the gradient boosting algorithm works. So it's taking the errors. From the errors, it is trying to take additional information and is trying to make a prediction even better. Again, it is looking at errors. Again, it's taking whatever information is left out in the errors. Again, it is adding back. Again, it is taking errors. It's like distillation process. Whatever information is available still in your errors, it will keep taking that information and keep adding it. So that way, your model accuracy will keep on increasing. Okay. Obviously, we should not overdo this. When you overdo it, what will happen? Overfit. You stand a chance to overfit, basically. The rationale here is not to overfit. But if you keep running it multiple number of times, then obviously you'll have overfitting issues. That is exactly what is written here. Okay. When you find time, just read this. Okay. Is there anything that I missed out? Okay.